Welcome to the last video of sections 2.9, 2.10. In the last video, I told you we were going to do example 3. I'm going to leave example 3 as something that you can try to do and set up. They are looking for the instantaneous rate of change. That's another name for the derivative. So we're looking for g prime, and we're looking for g prime at x equals 4. So we're actually looking for g prime of 4. Other than that, you're just practicing doing the quotient rule. I'd rather use this video to look at some setups like the ones on the bottom, where we are given functions in terms of graphs, and we have to find the derivative of that function at a specific point. I'm actually going to do B and D, and then I'll let you do A and C as practice if you want to check it when we get to class the next time. Excuse me. All right, we're looking for the derivative of k, but k is a quotient setup. I have a numerator divided by a denominator. So we have to do the quotient rule. We don't have a choice this time. So the quotient rule says, take the derivative of the top times the bottom minus take the derivative of the bottom times the top, all over the bottom squared. And I'm going to put the bottom f of x in brackets and square it that way. I'm also going to change this color to black. All right, this is my setup. The derivative of the top times the bottom minus the derivative of the bottom times the top over the bottom squared. Why do you think this is maybe a problem for some students? What do you notice about this setup? In this context, in this problem, my g of x is on top and my f of x is on the bottom. And so some students will look at this formula and they're like, wait, I did something wrong because all my notes that I took, this looks different than the notes that I took, right? Like here, f prime was on top, was first, g of x was on the bottom, but over here in this problem, it's backwards. We always follow the context or whatever the given function they tell us is, and then we apply the quotient rule. So if you haven't heard me say, as I'm writing it down, I never say f prime of x times g of x. I always say the derivative of the top, whatever the top might be, times the bottom minus the derivative of the bottom times the top over the bottom squared. So that helps me not, I don't necessarily need to remember the f of x and g of x and f prime and g prime. I just need to remember who are the characters in this formula. Oh, there's a numerator top, there's a denominator bottom. That's how it works. All right, but we wanted to find k prime of 7. So let's find k prime of 7. That means I'm going to substitute a 7 wherever I see an x. Oh no, that was all connected. I'm hoping that I can erase quickly rather than rewrite it all over. But it seems like that's not going to be possible. Whoop. Oh, well. It would have been easier to maybe just rewrite it with 7s. Okay. So now I'm going to go to my graph, and I'm going to figure out all of these values. So we're going to start with g prime of 7. So we're looking for the slope of the graph of g at 7. So at 7 on g graph, that would be this one. What is the slope of this line? Well, if I start at this corner and go to this, if I start at this endpoint and go to this endpoint of this line segment, I think it's down 1 over 1, down 1 over 1, down 1 over 1. So my slope is -1. And then I go to the f graph and find out what's the y value at 7. So the f graph, what's the y value at 7? Why is it doing blue? That's weird. What's the y value at 7? That would be 3, right? This is the graph of f. And so at f, the y value or the function value is 3 minus the derivative value at 7 on the f graph. So what's the slope of this line? Well, I think it goes up 1 over 2, up 1 over 2, up 1 over 2. So it looks like the slope is 1/2. And then we find g of 7. So what's the y value here on the g graph when x equals 7? I believe that's 4. And we said that f of 7 was 3. So then this is just 3 squared. This is what's going to produce my answer for this problem. We're going to multiply -1 times 3, that'd be -3, minus, we're going to take 1/2 of 4, that'd be 2, and then 3 squared, that's 9. So my final answer is -5/9. This is my derivative value for this function k at x equals 7. That's it. Again, we're practicing doing the quotient rule, but this time, after we set up the quotient rule, we substitute the 7 as my input, and then we find whatever it is we're looking for. If they give us the graph of f and g, which they did, then whenever we're looking for f prime or g prime, we're looking for the slope, and so we just find the slope of that segment. D is the last one we'll do together, and then we'll practice some quotient rule on Friday, or in the next class period. Let's see. So we're going to find w prime of x. Again, if I think of this as a top and a bottom instead of an f of x and g of x, then we're going to find the derivative of x squared. The derivative of x squared times the bottom, which is g of x, minus the derivative of the bottom, which would be g prime, times the top, which is x squared, all over g of x squared. All right, this is what we have to find. So let's start working it out. I need to find the derivative of x squared. The derivative of x squared is just 2x times g of x minus g prime of x times x squared all over g of x squared. And that is our derivative. Oh, but they want the derivative at 2. So let's go back and let's substitute a 2 wherever I see an x. And then we'll evaluate that. Let me do this, and there you go. Yeah. And I'll do this there. So wherever you see a purple 2, that was where an x was. I inputted or replaced the x with a 2. And now we can figure this out. Let's hope. 2 times 2 is 4 times g of 2. So we're looking for the y coordinate at x equals 2 for the function g. For the function g, that would be this one up here, and that looks like it's 7. So the function value of g, yes, is at x equals 2 is 7. Awesome. Minus, that's a multiplication dot, g prime of 2. Well, g prime of 2 is the slope at x equals 2. Well, the slope at x equals 2 is 0. So therefore, that was easy. 0 times 2 squared, that's 4. It really doesn't matter what 2 squared is because when I multiply it times g prime, which is 0, it's going to go away. And then g of 2 we said was 7, and we're going to square that. So in effect, we're left with this goes away because 0 times anything is 0. And then I noticed that I'm multiplying by 7 here, and 7 squared is 7 times 7. That means a 7 from the numerator and a 7 from the denominator are going to undo each other. And so my final simplified answer is 4/7. And that would be the derivative value of the w function at x equals 2. If you understood the idea that whenever we're multiplying functions, we need to do a very specific setup called the product rule to find the derivative. The same thing applies whenever we're dividing functions. We need to use a very specific setup called the quotient rule in order to get the derivative function. That's the key to this week's notes, I guess, or the new stuff this week, is that we definitely have function rules like the derivative rule for e to the x, the derivative rule for sine x, the derivative rule for a power function. But then we also have like operator rules. What happens when I'm multiplying or dividing? I have special rules that I need to set up in order to figure out those derivatives. Addition and subtraction, I mean, those are pretty straightforward because you're just adding the derivatives that you have of those terms or subtracting. But multiplication division, we have to use the product rule and the quotient rule. We'll do more practice in the next session so that you can get more comfortable with these rules.